Again, I am quickly sharing the link to the WhatsApp group. It is also in the presentation, but you can send me a WhatsApp, and then just another link that you must please complete, and that's the attendance register that I will put in the link now, or in the chat. So please find the attendance register as well, and I will post this later again. Okay, so tonight we continuing. So last week we looked at functions. The week before that we did introduction to previous work. So tonight we're focusing on linear systems, which is chapter 3, and next week we will look at chapter 4, the mathematics of finance, where we will be looking at simple interest, compound interest, and more things like that. But tonight we're focusing on linear systems. Okay, so again, how we will approach it, we'll work through some of the theory, and then we will also at the end work through some examples, so that we can prep you for your assignments and your exam that will happen later. So let's get into the linear systems. Okay, so in the linear systems, or basically linear equations, we're gonna look at a few things. So we're gonna look at linear equations where there's one variable. So basically something like 2x plus 3 is equal to 6. So that will be where we will look at, say, one variable. So solving something like an equation like that. So that will be where we will focus on one equation, or one variable in an equation. Then we're going to look at the equation of two variables. So there it might be that we look at some of the straight lines. So something like y is equal to 6x minus 4, or something similar in that extent. So firstly, we look at the one variable, then with two variable, and then we're gonna look at the same thing, but now we're looking at inequalities. So where that same formula will just have a bigger or smaller than sign in it. So the only difference now is that the inequality will be something like 2x plus 4 is equal to 6. And for two systems, y bigger or equal to 6x minus 4. So that is the biggest difference just between the linear equation and the linear inequalities. Okay, so still the same type of equation that we're working with, just a different signage in it. And this mostly make a difference when we come to more the later part of the work, where we look at this type of linear representation, but we get to that later in the session. Okay, so basically they can ask you to solve for one variable, they can solve for two variables, and then basically what is separating it is an equal sign, or then one of the inequality signs that we need to deal with. Okay, so that is the first thing. Then I nearly said it now, how the linear equation will look like, but basically it is, and again, depending on study guides and textbooks, and if you Google linear equations, you might get a few different views of how a linear equation will look like. So you've got the standard linear equation where they talk ax plus b is equal to 0. This might also be, in some cases, called mx plus c equal to 0. So just be, in some instances, they use the traditional a as the coefficient and b as the constant. In some areas, if you're going to Google linear equations and you want to look at a YouTube clip or some other way of explanation, it might also be that they talk about mx plus c. Okay, so just if you go and look, just be wary that there is two ways of representing that. We'll look at the same when it is two variables. So the first thing is that we're going to look at two examples where you can see we're only dealing with one variable. We have the equal sign. Here again, one variable, equal sign, but just a bit different in that there is a numerator and not. So first, you guys can try. I'll give you like a minute or two just to start with the first one, and then I'll start off with the explanation of that, and then we'll look at option 2 as well. Okay, so let me just, as the guys are joining, let me just post again WhatsApp group, the link to the WhatsApp group. All the recordings and the presentations will be posted there, and then just also a link to the form registration or the attendance register for tonight. Okay, so just on that, I will later tonight post the recording on our WhatsApp group, and also the presentation. And if there is people joining only tonight, I will also repost the first two sessions that we had as well. So that's just everybody that may be joining late. So also the guys that are watching the recording, if you're watching the recording and you're not part of the WhatsApp group yet, just send me a WhatsApp on 0837908387, and I will add you to the group. Okay, so let's look at the first example. So basically, we need to simplify and solve for x. So in the first session nearly, we looked at order of operations. So first, we will need to work out what is in the brackets. Then normally take all the x's to the left, all the other numbers to the right. So let's just let's just do that. So let's first do solve what is in the brackets. So minus times the 2x is minus 2x. Minus times a minus 3 is plus 3. And you guys can feel free to post your answers in the chat as well. So then I'll take all the x's to the left side. So minus 2x on the right hand side. If I take it over, the minus 2 becomes, and let's now skip a stage. So that to the other side will become plus 2x. And then on the right hand side, I want to get all the numbers. So the plus 3 on the left hand, if I take it over, it will become minus 3. So we've got minus 3 plus 6 plus 3. So 4x is equal to minus 3 plus 3. So that cancels out. So we're sitting with 6. So x is equal to 6 divided by 4. So not a whole number. So 6 divided by 4 is 1.5. So again, I'm now not showing options A, B, and C, and D, but now it might be that they show this as the final answer, they might show this as the final answer, or they might even show 3/2 as a final answer. So again, let the answers that you get nearly, or look at the answers on the assignment, and let what you need to get to guide you. They will not give you the options of all 3 of them. So they will not do that because any one of them are correct. So they will need to tell you you're looking at the decimal or the improper or whatever. So they can't give you all 3 as an option. So just nearly let the answer set guide you in how far you need to simplify it. Okay, so for this one, x was 1.5. And what you can always do is put that answer back in the original and actually see if it works out. So let's just put it back. 2 times 1.5. Okay, so let's see. 2 times 1.5 is equal to 3. 3 plus 3 is equal to 6. So on the left-hand side, we've got 6. On the right-hand side, 2 times 1.5 is 3. 3 minus 3 is 0. 6 minus 0 is 6. So we can see that our answer was correct. So again, in the assignments, in the exam, test your answer. If you don't feel you have it right, or you worried about your answer, put it back into the original and actually see if it works. Okay, so now one where we actually have it as a fraction. So I don't want to work with fractions, so the easiest is to say, okay, let's multiply both sides by 42 over 42. So we're multiplying by 1. So we are allowed to do that as long as we do it on both sides. It is not a problem. Okay, so in the brackets, so 42, 4 minus 5x. So for now, I just gonna put down the whole equation that we're working with, and we can simplify. Now, so we've got the 42 times 1 minus 2x divided by 3. And then on the other side, remember we need to multiply by 42, across. What did I say? 42 over 42, sorry. We're just multiplying by 42 across. So 42 times 13 divided by 42, we will need to solve that as well. Okay, so that's the first line. We multiply by 42 across. You're allowed to do that as long as you do it consistently on both sides. We could have multiplied by anything else as well, but for me is I'm nearly looking at the biggest number, and that is the one that I'm working with. Okay, so now we can do a bit of algebra. So 42 divided by 6, so 6 goes into 6 in 1, 6 go into 42 7 times. So I'm just going to rewrite that one so long. So as we finish each one, I'm just going to rewrite it. Remember, we've got the minus, so remember to keep the minus. The 3 goes into 3 once. 3 goes into 42 14 times. And then we still set with the 1 minus 2x. And then 42 goes into 42 once, and 42 goes into 42 once. So we are left with 13. Okay, so got rid of the fractions because once again, I don't like working with fractions. It just makes your work so much more difficult. You're working with the fractions. So now we can simplify a bit. So 7 times 4 is 28. 7 times 5 is 35. So remember, there's a negative in front of it. Want to see what happened now with the screen. Okay, so we're done with that. So now we minus 14 times 1 minus 14. Minus 14 times minus 2 is plus 22x. And on the right-hand side, we still have the plus 13. Okay, so now let's see if we add all the x's together. We get minus 35x plus 28x. So that is minus 7x. And now we take all the whole numbers to the right-hand side. So let's first 28 minus 14. The 28 minus 14 is 14. If we take it to the other side, it becomes minus 14. So we now sit with minus 7x, which is equal to minus 1. So if we divide on both sides with minus 7, we get x is equal to 1 over 7. Okay, so let me just change color. So we'll get to x is equal to 1/7. Okay, so we end up with a fraction. So again, if we want to test that, sure, not really going to be that nice, but let's see. So let me quickly, just going to duplicate this. Let's just quickly see what how we can get to it. Okay, so let's say that was the answer and we want to test it. So, and now we can nearly revise a bit of our previous work as well to see if we can work with the fractions. But I'm also going to use my calculator in this because there is just no ways that I think this will be a easy way of just getting to a simple answer. We could have, okay, I'll also, okay, so let's quickly, so that is 4 minus 5/7 divided by 6 minus, and then 1 minus 2/7 divided by 3, which is equal to 13/42. But let's quickly see if there's any easy way to do this. Otherwise, it is 3 and 2/7. I see in the end, we will in any case need to do something with it. On this side, 5/7. So again, just by looking at those numbers, 2 divided by 7 plus 3. So I am just going to quickly make a calculation on my calculator. So that would have been something like, if I said 3 and 2/7 divided by 6, and on this side, set 5 divided by 7 divided by 3. And you guys can, if you have a nice calculators that does work out your fractions and you can use it, please do. I don't have a calculator like that. So let's then check what 0,5476 minus 0,2381 is. Yes, we will get to a estimated number, but that is fine. And let's just see if we set 13 divided by 43, we also get 0,3095. So again, we just checked if the 1/7 is correct. I didn't now want to, I'll get to the question now. I didn't want to simplify here and again multiply out. I just wanted to see if I replace the x with 1/7 and I work it out, and I get to an answer on a calculator if I get to the answer, and yes, I do. Yes, there's a hand. Please ask.
Good afternoon, sir. How are you?
Good, and you?
All right, thank you. So I'm sorry I joined late, but I just want to know, I understand fully what goes on, but they had the second step in the read on the right. I just want to know, I think you were doing lowest common multiple, if I'm correct, by the
Yes.
42 you were timesing by. But I just wanted like to know that second step. How did you go about that? That's right next to times 42. So I don't
Okay.
really understand that second line.
So this line that I now indicated with blue.
That's correct, yes.
Okay, cool. So I got the lowest common, which is 42. So what I did was to say, I'm going to multiply everything by 42 because I'm allowed to do that. So I said originally 42, I'll put that 4 back, 42 times 4 minus 5x,
Okay.
42 times the 1 minus 2x, and 42
Yes.
times the 13.
Yes. And then the lower part underneath that, what happens?
So the lower part stays the same. So I
It's
just
still going to be
multiply.
6.
It's still going to be 6. It's still going to be 3. It's still going to be 42. And then I simplify. So then I say 6 goes into 6 once. 6 goes into
Um,
42 7 times.
oh, the 7. Okay.
Yes. 3 goes into 3 once. 3 goes into 42 14 times.
Okay.
42
Okay.
goes
Now I
into
understand.
42 once, and 42 goes in 42. So when you can see nearly the next step, I just simplified it so that
Perfect.
there's the 7, the 14, and the 13. Cool.
Okay. I'm now I'm on track. Yeah. It's just that step I got confused because then you obviously you lose the 16 and the 3 or the 6 and the 3, sorry. Because it's
Yes,
over, it's 1. Yeah. Okay, it makes sense. Thank you
exactly.
so much.
Exactly. Perfect. So yeah, anyone please ask. And it is, yeah, if you come in a bit late and I'm busy, just say stop. Also repeat, please, yeah, because you could have maybe seen it as 16 at the stage and then also don't know where the 16 and the 42 suddenly comes in. Okay, and I just always like in the previous one, if you have time, um, and you're not sure about your answer, test it. You can always put it back into your answer set. And that is, a few years ago, I had a student that what he would have done is, if you got, and he was actually very clever. What he did, so if he got this set to say simplify for x, and he was given 3 or 4 answers, he would just put that answer into X and see if it works out. So the one that works out then must be your answer. So if you really don't know how to solve this and you get 4 answers for X, put in the first one and see what your answer is. If it doesn't work, put in the second one. Yes, it does take a bit of time, but there are always another way to maybe solve these questions. There is another hand. Please ask. I think Kanye, can you hear me? You can ask your question, else we will just continue.
Hi, Jean.
Aye,
So I just recently joined. So I wanted to inquire about the testing, the
yes.
testing that we just did. On the second step from the equation. So I was trying to determine as to how we got to having to find the 2/7 by
Okay.
6. Yes, because I do see on the second step where you dropped down, where you are multiplying sorry, you're minusing the 4, the 5/7. So I could take it that you multiplied 5 by the numerator.
See, so here you can do a few things. So here you could have said, so all that I did was to say, okay, I know 5/7. So what is needed to make it a full one is I need to add 2. So 2 plus 5 would have given me the 7. So that is where I got the 2/7 from. And then obviously to get there, I need to take 1 away from the 3. So that is how one way of doing it. The other way is to say you could have, which will also make probably more sense, is to change this also into a fraction, because now again this is becoming difficult because now you sit with 3 and 2/7. So another way to have done it is to say we can change that 4, which is actually 28/7.
Oh, okay. So basically, how we would be working with around the multiples that go into that whole number, if we're to
Yes,
change it into the fraction.
yes,
All right.
yes, yes. And yeah, I hate these fractions. It is just because it is so easy to make at any step nearly a mistake. Especially even if you look at at this that we did originally, it's so easy to make a mistake in this. So I really hate the fractions, especially when it's a bigger number. If that was 18, where it was 6 times 3, nearly to get to 18, that's actually nice. When it becomes the 42s, and then it's just very easy. So even testing this, I should have probably, I would have, in the normal circumstances, probably would have first changed it again to the like a 28/7 minus 5/7, because then you get 23/7. So that is probably what I would have done, but the problem still sits that you will divide by another number. So if you get a question like this and you want to test it, I would use from the start the calculator, and just put in the numbers. So I would have, even at this stage, I would have just said 5/7, give me what that is, subtract it from 4, and then divide by 6. So I would nearly, if I needed to work this out, I probably at this stage, I would have used my calculator already, and to get decimals, and not even looked at this, just so that I don't make more mistakes, especially with the factors. That is just how I would have, sorry, with the fractions.
All right. Thank you so much. Now it's more clearer now.
Cool. Thank you. Yeah.
Thank
So
you.
please stop and ask. Cool. Okay. So this is when we were looking at where it is an equal sign. So if it was bigger or smaller, we would still do exactly the same. So in that instance, if it was smaller, or then our final answer will just be smaller or equal to 1/7. So the process to get to your answer will be exactly the same. So I think that is sometimes we see the inequality, and then it's like, okay, but what do we suddenly do? You do exactly the same as you would have done with the equality, or with the if it was equal to. So if it is an inequality, please don't let that make you afraid of what you need to do, because again, I also sometimes you see this massive inequality, and you're nearly put off by the inequality sign, where if it was equal to, you would have made the changes and followed the process, do exactly the same if it in this instance was something like that. Okay. Let's quickly look at when we deal with two variables. So again, nearly you will see a few standard forms. So there's the yx plus by plus c. So that can be one form that you can see it in. They love to ask the y is equal to mx, and again, it might be mx plus c in some instances, it might be mx plus b. So again, if you Google and you look at YouTube videos, there is again just a few different ways that they might write it. So I think that is just important, nearly from it's not wrong if you write it this way. It's not wrong if you write it this way. So any one of those will be correct. Okay, and then again, if you look at those formulas, when it is an inequality, the only thing that changes again is that two signs that will become bigger and smaller than, or sorry, bigger and equal to, or smaller or equal to. So that is just where the inequalities will come in, is at that sign. So again, not really a difference in how we're going to solve certain of the numbers. It might just be when we later get to some of the graphs, that is where we will pick up some differences in how we analyze it in the end, or what our conclusions is in the end. So, but again, if you look at going to Google some YouTube clips around this, just remember that there is two ways that they can represent a linear equation, and most likely when you get the y is equal mx, it is normally mx plus c, because the c is also always seen as a y-intercept. So it is a bit confusing in a sense, where you suddenly, in this instance, you have it as a constant. So yes, it's a constant, but now in this one, it is seen as a b. So they will not, and as we will work through it, I'll show you examples of it. But if you look at something like this example, and we needed to make y, so these two are not the same. So if we made y the object of the equation, so let's just make that, so we will divide everything by 2. and 0 divided by 2 is the 0. So here we will have 3 over 2x. Here we would have had plus y, because 2 divided by 2 is y, minus 1102. So they should have just made that a better number, which is equal to 0. So then on this side, left-hand side, we sit with y. And then on the right-hand side, we would have had 3 over 2x plus 11 over 2. So just these two are not the same. Those two are also not the same. That is just all. They should have actually had the same example instead of differences. But if you needed to rewrite this equation into the other one, this is how it would look. They can give the equation as this one, so the standard form. They can give it in the slope-intercept form. They rarely give it as a point slope form, but they might also, but this one I really haven't seen in any of your assignments up to now, or anything like that in previous exams, or they normally ask the standard or the slope intercept. Okay, so let's quickly look at a few examples. So now, yes, we're sitting with two variables. We need to solve that. Going to be the same on our other side. So now there's a few ways that we can do this. So let's quickly do one, and let's call it option A. So we can say that is the first formula, that is the second formula. So we can look at this and say, okay, but let's say formula 1 minus formula 2. So that is 5x minus x is 4x. 2y minus 2y is 0. We just say plus 0. And 13 minus 9 is 4. So that gives me that x is equal to 4. Then I will replace x into one of those formulas. So let's put it into the second one. So we can then say 4 plus 2y is equal to 9. And then 2y is equal to 9 minus 4. So y is equal to 5 over 2. Okay, so that's one way of doing it. Another way could have been to say, and let me quickly do that, so that we just do. So another way could have been to say, okay, but let's change the second formula, and let's just make x the subject or object of a formula. So if we change that so that x is equal to, we can get x is equal to 9 minus 2y. And then we can say, well, I've got x here as 9 minus 2y, so I can substitute the x in the first equation because I know x is 9 minus 2y. So I could then have said, okay, well, 5 times 9 minus 2y is actually equal to 13 because I know x is equal to 9 minus 2y. Okay, so then long process, but multiply in, so 45 minus 10y, I hope I get the same answer, is equal to 13. So minus 10y is equal to 13 minus 45, which is 53. So now that is not the same. So let me just quickly check. 5, that is 9 minus 2. 5 times 9 is 45. 5 times that is 10. This is actually interesting. It should actually give you the same answer. But this is definitely not giving you the same answer. So let me just, so this is now a good check to see if I calculated it correctly. Yes, so please say to me where I made my mistake.
Sir, you were supposed to make 5 brackets 9 minus 2y plus 2y as well. You forgot the 2y.
Ah, thank you very much. Thank you very much. I forgot the 2y. Ha! I would have, thank you, thank you, thank you. And so easy to make that mistake. I totally forgot that. So I replaced the x, but I never added the 2y. Thank you very much for that.
Sorry, sorry, sir. I'm sorry to disturb you. Can I ask before you proceed?
Yes, you can. No problem.
Okay. At the top where you said equation 1 minus equation 2, ne, where you
Yes.
said 4x plus 0 is equals to 4. Were you not supposed to get x as 1, where you say 4 divided by 4 because we're looking
Thank
for
you
x?
very much. So, I've made a few errors here. Thank you, thank you, thank you. So let's just quickly, that's why I should have checked that one as well, because normally you will not get a fraction when you do this. So let's quickly, thank you. So that was 5x minus x is 4x. So that is at least right. That minus that is 0. That is, so divided by 4. That should be 1. Okay. And then, okay. Made a few mistakes in this one. And it's just because I didn't look at it. There I should have. So x1, again, you can put it into any equation. I put it into that one. So x 2y is equal to 9. Now I must make sure I get this right. 2y is equal to 8. Y is equal to 4. Okay, so let's just x1, y4, that looks much better as an answer because you will very seldom in this get fractions or things like that. So now let's just make 100% sure again. I said I'm going to replace x. Okay, so this one is just making sure we did the 9, we took that over, so that is still correct. We replace that there, so 5, 9 minus 2y is still correct, plus 2y is still correct, equal to 13, still correct. So now again, 45 minus 10y plus 2y is equal to 13. So on this side, minus 8y is equal to 32, minus 52. So y is equal to 4. So we get the same. And then if I put 4 into any one of those equations, I would get x equal to 1. Okay, so sure, I made a mistake there. Then I made a mistake there as well. Then I made a mistake there. So 10 minutes later, if it was exam, I would have wasted so much time because I did not concentrate. At least by testing it, I would not have gotten an answer. I would probably also not have gotten an answer because this was just a silly mistake. So I would have probably, when I gotten to the Y answer, I would have probably seen, oof, I don't have an X4 and a Y 2.5. Then I would have started all over again. Yeah, so, but I just wanted now to show there's 2 ways that you can do it. And please don't make silly mistakes as I did. And thank you for picking that up. So you can choose any one of the two. Some of the calculators can do it as well. So some of your calculators will be able to do it. I'll get to the question now, Kanye. And then there's also, if you want to test for online, you can, there's a nice online calculator. So I know with some of the other subjects, we're not sure again if you guys are allowed to use the online tools in the exam, but there's really a nice online equation solver that you can put the same things in. So I just want to share this with you. I'll share the link in the chat as well. So we could have had 5x plus 2y is equal to 13. We could have had the x plus 2y equal to 9. Just we don't have the equation 3 or 4. And when we computed it, we would have gotten the same x1, y equal to 4. Okay, so I am going to put this link just in the chat as well for you, because again, sometimes you want to test your answers. Again, we don't, if you have one of the sharp or cashiers that can do it, you can check it, but also use that online calculator just to test your answers. Yes, Kanye.
Okay, thank you. So I just wanted to ask, so on both equations, the equation, the tester, I fully understand. I just wanted to determine here by 45 minus 10y plus 2y. So when we take the 45 to 13 on the other side, because we have to be left with the negative 10y. Does the 45 become positive or a negative?
Yeah, so because we take 45 away from the left-hand side, we basically will subtract on the left-hand side with 45. So we need to do
Okay.
the same on the right-hand side so that it becomes negative 45. So then we would have had 13 minus 45, which is negative 32. But here we have minus 10y plus 2y, which is
A
negative
negative,
8y.
yes.
And then negative divided by negative becomes
Is
a
a positive.
positive. Yes.
All right. All right. Thank you. I just wanted to
Cool.
clear that one up.
Perfect.
Thank you.
No, so ask, please ask. That is very important, that because you will get something like this in the exam. So yes, you get it in the assignments, but you will get something like this in the exam. So we need to make 100% sure that when you get it in the exam, you can do it. So please, anybody, please ask when we have things like that, that we can clear it up. Cool. So let's look at the second one. So now you guys can just start with it. You can use any method. You can check it on the online one as well. So if I look at this and I marked that one as 1 and that one as 2, I see something nice here that again the y's can maybe cancel out. So where the first one was 1 minus 2, yeah, I would have said, okay, let's say 1 plus 2. So then it is x, now I must not make mistakes, x plus 3x is 4x plus 2y minus 2y is 0. And then it is minus 5 plus minus 3, which gives you minus 8. So in this instance, x would have been minus 8 divided by 4, which is then minus 2. And then again, I can replace it into any two of those. So I would replace it in the first one. So minus 2 plus 2y is equal to minus 5. So if that goes over to that side, we get 2y, that becomes positive. So minus 5 plus 2. And so now actually we're getting again something that seems a bit off, which is then y is equal to minus 3 over 2. Oh, so does that look correct if I put it in there? So let's quickly check on the online calculator. So we had x plus 2y is equal to minus 5. We've got 3x minus 2y, which is equal to minus 3. There is no third or fourth one, and we compute. And we get x is equal to minus 2. and the y was equal to -3/2. Okay, so what we did was correct. This is, sometimes I will look at this and say, look, somewhere I made maybe a mistake, because most of the times you will get the nice numbers, nearly the equal numbers, the positive numbers. But probably with these numbers, we should have expected answers to be negative in any case. So again, you can have done it in a different format as well. It will be the same. You can test your answer on the online tool as well. I still, if any of you guys have one of your study letters or touch letters, I just want to see what you're allowed to use in assignments and exams, and what apps they're doing to regulate what you guys are doing, so that we can just see if you're allowed to use any of these online tools. Um, for the assignments, there's no problem, but it might be that in the exam with some of the tools, they can see that you're using something online. So let's just make 100% sure that what you're allowed and not allowed to do and use in the exam. Okay, so if it was again inequalities, the only thing that would have changed is the signage. Your answers will again be exactly the same. Okay, so signs of inequalities, and what you will get is for greater than, less than, and sometimes they put in greater than or equal to, less than or equal to. What you're not really going to see in these equations, but it's just good to know, is the not equal to. But again, I have not seen any of your assignments or exam where they actually give you a not equal to question. Okay, so inequalities, we will quickly go through the same format as the previous one. We've got two examples where we've got inequalities with one variable. So again, we do exactly the same as we did with the when it was just a linear function. So take all the x's to the one side. So we will have on the one side 6x minus 4x, which is smaller than, and on the other side minus 3. And if we take the 7, it will be minus 7. Then it is 6x minus 4x, which is 2x, smaller than minus 10, which then gives you x, if you divide by 2 on both sides, equal to minus 5. Okay, exactly the same as you would have done if there was an equal sign. You would have done the same practice. The only different now is that we're sitting with an inequality sign. Okay, the same if you look at the second example. Again, nothing changes to if it was an equal sign. We first need to work out brackets. So we first will work that out. So 2 times 7 is 14x. 2 times minus 3 is minus 6. So that, as if it was the equal sign, do exactly the same. And as the equal sign, now we take all the x's to the left-hand side. So 14x minus 12x will be on your left-hand side. And we take all the numbers to the right hand. So minus 6 on the right hand will become positive 6. So we have 14 minus 12, it's 2x, smaller or equal to 12. And then x smaller or equal to 6. Okay, so very similar to if it was the equal sign, we do exactly the same. So if there's brackets, we work out the brackets first, then we work with the numbers, get all the x's, or if it was y's or whatever variable it is. I like always to get all my variables on the left-hand side, all the numbers on the right-hand side, and then you start eliminating to get to your final answer. Okay, so just, and I will probably do it 1 or 2 more times for the guys that might have joined during this session. There's a link to our WhatsApp group, and there's a link to the registration or tonight's attendance register. So if you can just complete that after the session tonight, if I see that there is new people that have joined the group, I will post, and yes, I do see there are people that joined the group. I will post again all the previous sessions, so that you can have access to that on the WhatsApp group. So I will definitely do that for you guys. So anybody that joined, I will definitely do that. Okay, so let's get to nearly the last set of questions. So it will be around the systems of inequalities in two variables. So here is again where we might, there's two ways that they can ask it. So let me rephrase it that way. So they might give you a question like this and say you need to solve it, or they might give you the set of inequalities, and they might tell you here is a few graphs and you need to solve and say which of these graphs or which one of the graphs is the best visual representation of inequalities. So that is nearly what they can ask you. So very important nearly when we look at this is, again, they will not ask you to draw graphs because it's online multiple choice. They can't, but they can give you a set of lines and say which one is the representation of that equation. So what we will normally do is we will get a picture like that, where we might get one graph, we might get another graph, and there might be another graph in there. And the one would have said, so let's say that's graph 1, that's graph 2, and that's graph 3. So the one equation might have been y smaller or equal to, so that we know it is smaller or equal to. The one might have here said y is bigger or equal to. So suddenly we now look at that area, and this second graph might have said also y bigger or equal to, and then so that it needs to be bigger than that, so lying to the top of it. So the only feasible area that includes that, and that is this one. So let me highlight it with a color. So that would have been the feasible area, because then it is y smaller, it is y bigger, and it is y bigger. By just changing that one of these, so let's say that was smaller or equal to instead of bigger. So then it is actually looking at that space. So when it's still smaller as it was there, it's still bigger as it was there, but now suddenly it's not bigger, it's smaller than. So now suddenly, just by changing that one inequality, we have a different feasibility area. So that's why the inequalities is so important to get right, because that might have been option A, that might have been option B. We can look at another option is, so if that was still like that, but this one was, and let's do another color, was smaller or equal to, okay, let's just make it a bit, so let's say that was smaller or equal to, so the third one, so then it would have been smaller or equal to, if that was still smaller or equal to, then it will be there. And now suddenly that one is also still smaller. Now we sit with this area. So just by looking at a few different changes in the inequality, we can get different options. So what will happen in your assignments and what will happen in your exam is, and you would probably have seen, and I think a lot of you were like saying, some said that attempt 1 and attempt 2 was different. Others said attempt 1 and attempt 2 was exactly the same. So what will happen in your exam as well is that for the one set of questions, you might have gotten the first one that we did, that was your three equations. A second paper might get these equations. So it might be that there's three different sets of equations, but you're writing on or three different types of papers. So again, that's why we also, and that's nearly why we also don't want people to share or ask for assignment answers, because there is so many options or permutations that can be in the exam that you basically are not able to really cheat because they give you different options. So just again, be very careful when you look at these, because by just making one mistake on it, you could get a different feasibility area. Okay, we'll get to feasibility in one of the later questions. So let's first work it out mathematically. So mathematically, we would have done exactly the same as in your, with if it was an equal sign. So there we've got 2x, there we've got y. So I would have said there's a minus y plus y. So I would have said 1 minus 2. Oh, sorry, 1 plus 2. So 2x plus 4x is 6x. That will fall away. Minus 3 plus 5. So this is just to work out the x's. If I need to draw it, it will be something way different. So that will be equal to 2. So x would have been, so this is not how we're going to draw the same, because it will be different. And then if we needed to work out y, we will put that back into the equation and we will work out y. So what they wanted us to do here is, and that's why you won't nearly get it in this format, they wanted us to draw it. So let me just, so if we just put that back into the equation, we would have gotten something like, so I am going to show you how we would have drawn it, just so that you can get an idea, because I do think that is important, and how we will manipulate the formula a bit. But if we just wanted to work out y and x for this, we would have put that back into there. So it would have been 2, 1 over 3 minus y bigger than minus 3. So we would have gotten, and that is why we nearly see that we won't really work this out in a yx, but that 2 over 3 would have been subtracted on the left hand, so we will subtract on the right hand. So it will become minus 3, 2 over 3. So this is really not a great one to work out your x and y, but that is how it would have been just to work out the x and y. We didn't do anything else with this because I automatically changed it to the equal to get to the y and x. So what they would want us to do in this instant is to say, okay, but let's draw those two. And again, you will not need to draw it because they can't ask you to draw something in a multiple choice. But they might have asked you these two equations, how does it look in a simpler format? or things like that. So
Sorry, Jean.
yes,
Sorry. You lost me completely there by the coefficient of y. Were we using the 1/3 multiplying it by 2?
yes, yes.
Okay.
That
So that means then.
yeah.
So that means then we took. So that means we took. All right. Now I think I'm now getting it.
So you could have write it as 2 times the 1/3, because that is 2 times 1/3. And let's just make that a bit clearer, that is actually 3 and not some weird looking number. So you could have written it as that, or short form is to do it like that already. That and that is exactly the same.
Okay, no, thank you so much. I
Okay,
think I now got it. Yeah.
cool. So again, so please ask, because sometimes I write it quicker, but that is exactly the same to do that. So it just looks a bit different how we write it out, but you will get to exactly the same answer. Okay, so they might have asked you to simplify these two equations and said, let's make y the object or the subject of the equation. So the first one then is to say, okay, minus y, sorry, there is no equal. So minus y, so that we kept is bigger than minus 2x. So we will take that over to that side, minus 3. So that's the one formula. And the other formula is to simplify that is y. So that stays there, but it's minus 4x plus 5. Okay, so that would have been a way to rewrite it. Then something that you guys also, I don't know if we've covered that somewhere, but if you've got negative y and you now need to change, so here we have negative y and we need to change that to y as the subject or object of the equation. We need to get rid of that negative in front of the y. So we need to basically divide by minus 1, or much easier is just to say, well, across everything, I will multiply by minus 1. Okay, so if I multiply by y minus 1, minus times a minus 1 will give me a positive 1. Okay, so then I sit with the positive y. Okay, now what is important? So minus 2x times minus 1 becomes 2x. Minus 3 times minus 1 becomes positive 3. Okay, so we've multiplied out everything to make it now the y positive. The thing with this in inequalities, when you do that, if you change the the sign in front of the y, that has a direct impact on your inequality. So where we had the inequality bigger than, your inequality will swap around. Okay, and I don't know if that was at all part of any of your previous algebra or math work that you had, but in inequalities, that's basically the most important one, where it does not happen like that in if it's equal to, and let's just see why it is like that. So let's say this answer was mine, or y was equal to -2. So if we just put something in here, so you could see that, so let's say x was 6. So let's just solve and we put something in the value of x. So in this original one, will be bigger than, so -12 -3, so that would have been minus y is bigger than -15. So let's put 6 in the top one, or in the bottom one, sorry. So that would have been when y is smaller than 12 plus 3, which is 15. Okay, so if you see here, so y is smaller than 15, minus y is bigger than 15 or -15. So if we divide by -1 on both sides, we will need it to change the sign as well. So this is the only time where you would change the inequality is with if you change -y to +y. If it is x, it's fine. If you have it x on this side minus x, that doesn't matter. It is to do with the positive and negative y because of, we go way back, because of this equation. And then the inequality equation, if you look at this, because we want y to always be positive, because we want nearly to get the shade of inequality, or the area that we kind nearly reject. So we always want to nearly work with a positive y. Okay, so I'll show you in this example again how we will do that. I just want to see if there was another one. Okay, so let's quickly look at this one. So consider the following graph. Which of the following systems of inequalities is represented in the graph? Okay, so they actually give us that line. They give us that line, but they give it to us as how the linear equation will look like. Okay, so the first thing that we need to look at, so the highlighted area, or the area that is seen here, it's all lying in quadrant 1. So all my x's and all my y values will be 0 or bigger than 0. So again, it's not something that they always tell in the study guide, but you basically have one inequality here that says x must always be bigger or equal to 0. So that is why we suddenly have those two that have been added. And because it's also in quadrant 1, your y will always be bigger or equal to 0. If that feasibility area was, let's say, it looks something like that. Then it would still have been y equal or bigger or equal to 0 because it still lies in the top part of the graph, but your x would have been different because now your x can be smaller than 0 as well. So that then would not have been part of the equation set. Normally, we only work in the first quadrant. Okay, so normally we just work in the first quadrant. So we will always have, hopefully, that your x and your y's will be bigger or equal to 0. Okay, so if we do later on a recap of your first, second, and third assignment when we prep for exam, and there is anything different to nearly this, we will definitely go through it and also look at how we answer that. But normally you would get that it's only in the first quadrant that your equations will focus on. Okay, so let's then look at these two equations. So the one is x plus y is equal to 3. So there's x plus y. So they say it is bigger than that because, again, your feasibility area is lying to the top part of that. So it is actually x plus y is bigger than 3, but bigger or equal to 3. So y is bigger or equal to 3 minus x, or the same equation is minus x plus 3. So if we look at this one, it needs to be bigger than, because that is where the feasibility area is. So then we change it, it must be bigger or equal to. And then if we simplify, because you can see all of them, y is the subject or object of the formula. So we've got y bigger or equal to 3 minus x. So there is minus x plus 3, but it is equal, bigger or equal to, so not that one, bigger or equal to, so that one seems correct. Okay, it's not smaller. If it was smaller, it would have been lying to that side. So it's not that one. Y bigger or equal to minus x plus 3. So at the moment, we're basically between option C and D. Sorry for that. So already we eliminated that one and that one. Okay, so then the other equation was x plus 2y equal to 4. Again, we see in this, it must be bigger. So the feasibility areas shows that it must be above. So bigger or equal to 4. So again, if we rewrite it, bigger or equal to 4 minus x. And now we divide by 2 because, again, we want y to be the object, not 2y. So if we do that, divide by 2 on this side. So let's divide by 2 on both sides. So 2y minus 2 is y. 2 divided by, 4 divided by 2 is 2. And here it's actually minus 1. So minus 1 divided by 2 is minus a half. So it could be minus a half x, or it could be 2 minus x over 2. Okay, so both of those two equations is right. So let's just see how they represent it. So there we've got the positive 2 minus a half x. So that one is correct. So there you see they want to say smaller, but we know the feasibility is lying to the top. So that one would have been wrong, and that one would have been the wrong, so that we sit with that answer as your final answer. Okay, so that is how they will ask you, is give you that feasibility area with the formulas, give you the 4 formulas. You need to say which one is the correct one, or they can do it slightly different. So that one I want to take out because you guys are not doing that. So they could have done it a bit differently and said, okay, well, here we've got 4 inequalities. You need to say which one of these represent those 4 inequalities. So again, the 2 standard ones is x and y will be bigger than 0. So here we can see, well, that is in quadrant 1, that's quadrant 1, quadrant 1, quadrant 1. So all of them is 100% correct that that is quadrant 1. So we can't eliminate anything yet. So let's look at equation 1. So they labeled to us where equation 1 is, and they said that must be bigger or equal to. Okay, so that is 1. It must be bigger or equal to. Okay, so we can already now see, oh, that doesn't look like bigger or equal to, but let's just check all the other ones. Bigger or equal to. Okay, so that one falls into it. So that one does not fall into it. Bigger or equal to, yep, that falls into it. So that can still be. That one can still be. Let's look at, okay, nope, because it is to the bottom. So with that first formula, we've eliminated 2 of them. So let's see then. The second one says smaller or equal to. So now we've got that one, smaller or equal to. That is still fine. So we're sitting with this one, smaller or equal to. So again, incorrect one. So that is your feasibility area. Just to show it again to you guys. So if that second one was y bigger or equal to, then this one would have been your feasibility area. Okay, so just be, again, when you work through this again, just be very careful with the inequalities, because by changing that inequality, so if that first one again was smaller or equal to, then it would have been to this side. If it was to this side, then we would have had that one and that one. So then we would have had option 1 as your correct one. So again, just be very careful with the inequalities and which one they give you, because that plays a huge role in what your feasibility area will look like and not. We still have time, so this was a question last year in one of the assignments. So what they did with this was way different to anything else that the guys saw. So again, it was a bit strange because all of the time we just needed to look at inequalities and look at feasibility areas. So now what they asked was, and that's nearly where I think, let's just quickly check which of your study units. So in one of the previous study units, it was a small component of the work that looked at area and diameter and volume. It was very small component of the work. And suddenly they combined that with this into a question. So here they say, calculate the area rounded to 1 decimal of a triangular garden defined by the system of inequalities. Okay, so basically we've got this system of inequalities. X was bigger than Y or 0. Y was bigger, so we know it's all sitting in this area. We had this formula, so we're going to quickly, let's first do this so that we can get just the linear equation. So if we divide by 5, x plus y is equal to 12. So if x is 0, y is 12. So if x is 0, y is equal to 12, so that we can get that cut off. If y is 0, strangely enough, x is also 12. And now we sit with a line that, and I'm not going to try and draw that. Let me get those two. So now we sit with this area that we will need to actually calculate what is the area of this. So this is not something that out of this study unit you suddenly, I just want to get, sorry, that equation right, that it just lies on the okay. So it's easier to delete that component. Let's just do that. Let's draw it better. Oh, come on, John. Sorry about this. I am now frustrating myself with this. Okay, so just imagine that was the area. I am now not going to draw it over again. That's 12. Up until that point is 12. We will need to work out what this area is. Nowhere in this chapter at all did we have to do something like that. If you go through your study guide, you would not have needed to do something like this at all. But combine the previous chapter with this, and suddenly they can ask you to work out what that area is. And then the area of a triangle is half times base times height. The height, we've got 12. Base is 12. And we multiply that by a half. So a half times 12 times 12 gives you 72. Okay, so it might be that you get exactly the same question in your assignment. This was from last year, so it's not that we have broken any rules or anything like that. I just thought it is important for you guys to see also that everything in this chapter was basically looking at just how to solve X, how to solve Y. Then if you needed to use the feasibility, needed to look at equations. And then suddenly it asks you to work out an area of that feasibility. So again, what you will see in this question is there is a smaller than. So we've got that line, it is smaller than, so that fits that feasibility. It is bigger than, X is bigger than 0, Y is bigger, so it fits that feasibility, but it's the first time that we actually needed to calculate the area. They will not ask you to calculate that area because I don't even know what formula we will use. They will not ask you, so they might have asked you to work out that one area with one line. They will not ask you to work out those areas because who knows what that will be. So that you don't need to worry about, but they can ask you something like this. So I just wanted to add this from last year's assignment so that if you get it, you might just be prepared for something like this. Okay, so let me quickly, before we end off the session, I just quickly want to again just add the WhatsApp group so that we can just, for the guys that maybe joined the session late and didn't see, so the WhatsApp group link is in the chat. Then also please the attendance register is in the chat. And then the last one, if I can just ask you, there's also an evaluation form that I will add now also in the chat, that you can just complete that as well on tonight's session. So there is an evaluation form as well. Okay, so in the session tonight, we basically looked at, and we can nearly go back to the start, we looked at linear equations for one variable, linear equations for two variables, linear inequalities in one variable, linear inequalities in two variables. And then that last question, what we actually did was to say, but let's just look at that linear equations, and we combined it with one of the previous chapters where there's a small section where we looked at volume, area, and perimeter. Not to worry at all if you don't see your region on the register. You can send, so that you can also just, and hopefully you have access to the Cape Town portal, but if you don't, you can just send this email to ctn.unisa.ac.za. They will give you then just access to the Cape Town portal. It doesn't matter which region you are. Hopefully there is one that says other. I haven't looked at this attendance register. Let me just quickly, while we are chatting, let me just quickly go onto it. So you could, let me quickly, you said you are from Mpumalanga, then I would select, oh, that is quite interesting. Northern Cape, Free State, Northwest, they should, Northeast region. I will maybe select for now Northeast region. I will just say to Bronwyn for later on. I will just ask for the next sessions if you in Mpumalanga, which area, but at the moment, pick that north east, that region maybe. It is more for stats in any case for the Cape Town guys to, I will just ask them to update that we include Mpumalanga, that you don't need to guess between the regions. Okay, so a lot of you guys will see that in the next 2 weeks there is, and let me just stop the recording, we can just chat on. So